to do note 17 here, graphing polar. And I know you guys know how to graph it with your calculator, but let's see if we can figure out how to do it by hand. So I have an equation here, and all right, guys, focus, focus. So what I want is I want to be able to graph this equation. So I'm going to make a table. I'm going to call it R. No. I'm going to call it theta. And I'm going to call it R. And by the way, before I start, this is a polar grid. It starts at pi over 12. And then all these gaps are pi over 12 apart. Pi over 12, pi over 12, pi over 12. All those gaps are pi over 12, guys. And so what happens? Well, pi over 12 plus pi over 12 is 2 pi over 12, which reduces to pi over 6. See? 2 pi over 12 plus pi over 12 is 3 pi over 12. 3 goes into 12 4 times. So this next one's pi over 4. See? 3 pi over 12 plus pi over 12 is 4 pi over 12. 4 goes into 12 3 times, so this one's pi over 3. 4 pi over 12 plus pi over 12 is 5 pi over 12. This for a polar grid. And then, of course, 6 pi over 12, which is the same thing as pi over 2. And you can just continue on that pattern forever and ever. Yay or nay? Okay. So, it seems to have run out of space on that side, so I'm going to come over here. Theta and R. I'm going to choose theta. Usually when it's signed, you want to choose special values like pi over 2 and 3 pi over 2, but I know I'm going to start from scratch here. I'm going to pick 0. So the unit circle doesn't go away. Sine of 0 is, do you remember what sine of 0 is? 0. And 0 times negative 2? 0. So I start here at the origin. That's also called a pole, by the way. I'm going to plug in pi over 6. Sine of pi over 6 is a half. And what's half of negative 2? Negative 1. So go to pi over 6. It would have been this line in quadrant 1. But then I go negative 1. So I'm going to go in reverse. And I am now in quadrant 3. Yay or nay? Okay. I'm going to choose another value. Pi over 2. Pi over 2, sine of pi over 2 is 1 times negative 2. And I get negative 2. So I increase in magnitude. That's actually the biggest I'll ever be magnitude-wise, too. So let's see. Increasing magnitude, pi over 2 is the positive y-axis, but I go backwards, so I am right there. I'm going to choose 5 pi over 6. And then sine of 5 pi over 6 is a half, sine of 5 pi over 6, times negative 2. Half of negative 2 is again negative 1. So 5 pi over 6, I would have been in quadrant 2, but I go backwards, I am in quadrant 1. Quadrant 1, did I say quadrant 1? Quadrant 4. Sorry. And then finally at pi, I'm back at 0. So I'm going to go like this. There's the direction that I go. I go like this. And there it is. Cool, right? The biggest magnitude of that is this value. That 2, the magnitude of the R, the distance from the origin to the distance from the origin to here. That is 2. Where's the center? By the way, this will always be a circle. The diameter is 2. And if it just looks like that, if it just looks like this, the center is going to be halfway through. So at 0, negative 1 is the center. Center, 0, negative 1. And what's my radius? Half of the magnitude. So 1, or half of the diameter. So you will always get a circle. So I guess I'll write the notes here, guys. You will always get a circle when given R. R equals A cosine theta, or R equals A sine theta. A equals diameter of circle. And if you have this one, well, I guess let's do the one that we can see first. If you have the sine, one, center is going to be 0, comma a divided by 2. And if you have the cosine one, center will be a divided by 2, comma 0. Yay or nay? We're about to prove that. We're gonna prove it right now. So watch. How do I know it's a circle? Well, first it looks like a circle, but let's prove just this one circle. Did we prove it last time or no? No, we just did it by a graph. Man, I treated you guys so big. Don't you guys want to know all this little math stuff? Prove that this is a circle. We already did equations of circles, guys. Equations of circles, all of them look like this. Where do I write it? I'll write it over here. Equations of circles in rectangular form you can also say Cartesian form, looks like x minus h squared plus y minus k squared equals r squared, where h comma k is the center. So I'm going to make it look like that. So here's what I'm going to do. I take my expression, and I see that I have an r in it, so I'm going to multiply the left side by r. Whatever I do to one side, I do to the other. So now I'm going to have r squared equals negative 2r sine theta. And then I'm going to make a side note. You remember that x equals r cosine theta and y equals r sine theta. Well, there's my r sine theta. That's just the same thing as? The same thing as what, guys? What letter is that? Well, yeah, y. R sine theta is the same thing as y. And then r squared, remember that we get that by x squared plus y squared equals r squared. So I'm going to replace all that. X squared plus y squared equals negative 2y. Are we okay? Nothing crazy, right? I'm going to move this negative 2y to the left. Chav, what are you doing? I want to make it look like this with the r squared on it. I'm trying to make it look like that, guys. So I'm going to move the negative 2y to the left. So I have x squared plus y squared plus 2y plus blank equals 0. I'm going to take that trinomial and I'm going to complete the square. What's 2 divided by 2? 1. And what's 1 squared? 1. Whatever you do to one side, you do to the other. So here's what I have. X squared plus parenthesis y plus 1, close it, squared equals 1. OMG. The center of this circle is at 0, negative 1, and the radius is 1. Because it's r squared equals 1. And sure enough, that's what I had over here. Look. 0, negative 1, and the radius of 1. Cool, right? And I could, you know what? I should put absolute value here. Absolute value of A is diameter of the circle. Put absolute value. Yay or nay? Easy? Okay. Let's continue. Let's work. I'm going to call this number 2. That one's kind of hard. Let's go to number 3. Number 3 is just like number 2, but not as hard. And why are they not as hard? Because you got nice numbers. Okay. I want you to notice something, guys. You see this equation? Notice I'm writing y equals. If you cross the x-axis, because remember, I'm just doing this right now, y equals. Let me put an x instead of a theta. So theta axis, x-axis. If you cross the x-axis, you're going to create a loop. If you touch the x-axis, you're going to create a heart. This is called a heart. It's a lemicon. but it's called a heart because because of that little point there. See, that little point is touching the origin. This origin sometimes it's called a pole. So don't freak out. Cool or not cool? So what did I say? If you cross the x-axis, you have a loop. Why, Chav? Why? I don't understand. Well, I guess what I say, the displacement between the x-axis is going to be the magnitude or the difference in. Okay, let me tell you why. Let's just see. I'm gonna write a table here, and I'm gonna go theta and r, and you're gonna see why right now. I'm gonna start at 0. If I start at 0, sine of 0 is 0 times 4 is 0. So I'm just going to get a value of -2. So I'm plotting the value of -2 comma 0. So where am I at? Let's see. 0 is the positive x-axis. -2. I go backwards. Bam. I'm going to call that the very first point. Cool or not cool? All right. The next value I want to put, I'm trying to put perfect values on this. It's a sine, so I'm going to put pi over 6. Sine of pi over 6 is a half. What's half of 4? 2. -2 plus 2? Yeah, you can say it. 0. So I'm at the pole. That is 0.1, 0.2. We'll talk about... Oh, you okay, miss? Okay, we'll talk about how to connect it in a little bit. All right. I'm going to choose pi over 2. So look, at pi over 2, guys, don't worry, we're going slow. Sine of pi over 2 is 1. 1 times 4 is 4. -2 plus 4 is 2. Go to pi over 2, comma 2. Pi over 2, comma 2, point. That's my third. 1, 2, 3. I'm just going down the line. Pi over 2, what's next? I want to use 5 pi over 6. 5 pi over 6. Sine of 5 pi over 6 is a half. Half of 4 is 2, and -2 plus 2 is 0 again. So I'm back at the origin for point number 4. Now I'm going to use pi. At pi, sine is 0. 0 times 4 is 0 plus -2. -2. So go to pi -2. So pi is the negative x-axis. With -2, I go backwards. So bam. So that's number 4, or no, number 5. And I'm going to go to 7 pi over 6. We're almost done, guys. We're almost done. At 7 pi over 6, sine of 7 pi over 6 is a -half. -half times 4 is a -2. -2 minus 2 is a -4. So go to 7 pi over 6, -4. So let's see. 7 pi over 6 would have been in quadrant 3. But then I go backwards, so I'm in quadrant 1. 1, 2, 3, 4. Bam. That's number 3, 4, 5, 6. That's number 6. Does everyone see how I'm getting those points, guys? Okay. I'm going to put 11 pi over 6. No, 3 pi over 2. 3 pi over 2. Sine of 3 pi over 2 is what? Do you guys remember? -1. -1 times 4 is -4. -4 minus 2 is -6. So 3 pi over 2, -6. So I'm way over here. 1, 2, 3, 4, 5, 6. Bam. 3 pi over 2 is the negative y-axis, but the negative r makes me go up. That's going to be my 7th point. And then, let's see. Finally, well, almost finally, 11 pi over 6. Sine of 11 pi over 6 is a -half. -half times 4 is a -2. -2 minus 2 is a -4. 11 pi over 6 would have been in quadrant 4. I go backwards. So you are Let's see. Boom, boom. 1, 2, 3, 4. Bam. And then finally the last one, 2 pi. Sine of 2 pi is 0. 0 times 4 is 0. Negative 2 plus 0 is negative 2. So 2 pi, so full revolution, negative 2. I'm back here at that point. So this is number 7, number 8, number 9. I'm back here. Okay. How do I connect these points? That's the question. Obviously, you already have it in the notes there. But I'll wait for you guys. This is the super important part. If you can understand this, you can go to grad school and become a doctorate in whatever you want, medical doctor or whatever, because this is just logic. Okay, check it out, guys. And I know some of you guys are super tired. Notice between 0 and pi over 6, that's in quadrant 1. Yay or nay? There, remember, r is continuous. No way, there's no way that r will ever be positive between the point 1 and point 2, between 0 and pi over 6, because I'm going from negative 2 all the way to 0. You know what I mean? Like, the r is always continuous. So how do I get from negative 2 to 0? Negative 2, negative 1.9, negative 1.8, negative 1, negative 0.5, and then finally I hit 0. Does that make sense? So between 0 and pi over 6, r is always negative. So 0 pi over 6 is in quadrant 1, but because r is negative, I go from quadrant 1 to being in quadrant 3. So that means you connect 1 and 2 by going like this in a hyperbolic or circular method. So you're going to go like this. You're going to go, oh man. Oh, that's fine. You know what? That's fine. You're going to go like that. And now from 2 to 3, do I go through quadrant 1 or quadrant 2? I don't know. Let's see. Let's see. Here's point 2, here's point 3. Pi over 6 and pi over 2 is still quadrant 1, guys. But notice now r is, I'm going from 0 to 2. So I went 0, 0.5, 0.7, 0.9, 1, 1.5, 1.8. So all my r values, are they positive or negative? Positive. So I'm in quadrant 1 and r is positive. So that means I stay in quadrant 1. So you're going to connect point 2 and point 3 through quadrant 1, a circular feature like that. So I go like this. See? And then 3 to 4, there's only one way from 3 to 4, I guess, because you're not going to go back through quadrant 1, but just so you guys can make sure, look at this. 3 to 4, pi over 2 to 5 pi over 6, that's quadrant 2. And look, 2 to 0, so my r values are positive, so that means I'm in quadrant 2. So you're going to go zoom. So I come back, and I go zoom, see? And then from 4 to 5, how do I connect 4 to 5? Do I go through quadrant 1 or quadrant 4? Well, yeah, you can already see it. 5 pi over 6 to pi, that's quadrant 2. But look at your r. Your r is it positive or negative? Negative. So if I'm in quadrant 2 and my r is negative, I'm going to be in quadrant 4. So you connect it like this. See? 5 to 6. There's only one way to do that. 6 to 7. 7's way up here. There's only one way to do that one. 7 to 8. 8 is this one. And then 8 to 9. And look at that. We did it on our own without the assistance of a calculator. Was that cool or not? Cool, right? Okay, we're going to show you a visual of why that happens, guys. All right. This one here is going to create petals. Anytime you, well, you know what? Let's talk about it. So what do we want? I want sine of 3 theta to be either 1, comma, negative 1, comma, or 0. That's what you want. Are we okay? Yeah, I know. We're going to find how we get the petals. So look, guys, r equals 3 sine 3 theta. Look what you have in the front, 3 theta. I want it to either be a 1, a -1, or 0. So, what am I going to choose for theta? I'm going to write theta, comma, and then r. I guess the very first one I'm going to write is 0. Sine of 0 is 0. So I have a point at the origin. Point at the origin. Sometimes that's called a pole. Call it 1. Are we okay so far? All right. Next, what do I want? I want to get this to be 1. I guess I could also do -1 as well. I want sine 3 theta to be a 1. The only way to do that is if theta is pi over 6. Can someone tell me why I chose pi over 6? Think about it, guys. Sine of what angle gives me 1? What's the angle that will give me 1 for sine in radian? Yeah, not pi, but what? Not 2 pi, not pi and not 2 pi. Those are zeros for sine. Pi over 2. I need the inside to be a pi over 2, guys. So the only theta I can put in here is pi over 6. Because look, 3 times pi over 6, how many times does 3 go into 6? Or I guess you can just multiply it, 3 pi over 6. 3 pi over 6 equals pi over 2. Do you guys see that? So when I plug in a pi over 6, I will get a pi over 2 as the argument. So then this will be 3 times 1, which is just 3. If theta is pi over 6. See? So this is going to be 3. So you go to pi over 6. That's a second line. So this is pi over 12, and this is pi over 6. And at pi over 6, you put a point at 3. 1, 2, 3, point. And then if I go to, let me see. If I go to pi over 3, I am back at 0. Chaf, how did you do that so fast? Like this, guys. 3 sine 3 times pi over 3. Notice those 3's cancel out, and you just get sine of pi. And sine of pi is 0. So 3 times 0, the unit circle doesn't go away. So by the time I hit pi over 3 right here, I better be back at 0. So that means I look like this. Here's my first petal. I look like this. That's the biggest. There's my first petal. See? Does that make sense, guys? And I just continue. On that pattern. I just continue with that pattern. So let me continue with that pattern, guys. I'm going to put, let me see, what am I going to put? I need to get, I'll put 5 pi over 6 next. And then 3 sine 3 times 5 pi over 6 is the same thing as 5 pi over 2. 3 times sine of 5 pi over 2. And in case you don't remember, 5 pi over 2 is in fact 1 because this is pi over 2. This is 3 pi over 2. And then here's 5 pi over 2 on the unit circle. And then 7 pi over 2, see? So sine of 5 pi over 2 is also 1. 1 times 3 is 3. So it's going to look like, let's see, 5 pi over 6. The second one from the negative x-axis. And 1, 2, 3, point. And it's going to look like this again. And then if I put in 3 pi over 2, or is it pi over 2? Nope. Pi over 2. Which I should have put it in a long time ago, but that's fine. If I put in pi over 2, I get 3 sine of 3 times pi over 2. And notice that I get 3 sine of 3 pi over 2. Sine of 3 pi over 2 is -1, guys. So I get -3. So pi over 2 is the positive y-axis. Negative 3, I go down. 1, 2, 3, point. And it can look like this. There it is. Symmetric on the y-axis. Cool or not cool? All right, I know. Let me give you the hack, besides the calculator hack, how to do it without a calculator in case you're going to take the AP exam. All right, if you have something that looks like this, r equals a cosine n theta, or r equals a sine n theta, where n is an integer, like 1, 2, 3. It's a rose. It's a rose. If n is odd, you have n petals. If n is even, you have 2 n petals. Cool or not cool? And I'm just going to say, find where r is max. Find theta. Find theta where r is max. Sorry, guys. Just squeeze in a theta in there. Find theta where r is max. R is max, whatever the amplitude is of the A. We're going to do examples, like literal examples. We're going to do the activity again, but the right way. We're going to try to. And I'll show you like how to do it without the right way if you don't want to do it. Okay, last one. And then I think we're good for the real deal. On this one, guys, I want you to notice this. If this equation does not touch the x-axis, you do not have a loop. The amplitude is 3. Look where your midline's at, -4. So that means it looks something like this. -4 is down here. Amplitude is 3, so I go all the way to -1, 4, 5, 6, 7, -7. And I look, what's that, cosine? So I'm just, it's not going to be perfect, guys. Do I touch the x-axis? No, because you don't touch the x-axis, no loop. It's a heart. I mean, I'm sorry. It's this one, almost like a circle. It kind of flattens out. If it's a cosine, so Charles, so how do I know how this looks? You're just going to focus on the major points. Like this, watch. Theta and r. If theta is 0, look, there's the major points. Theta is 0, cosine of 0 is 1, -4 minus 3, 4, 5, 6, 7, -7. So I'll go to 0, the 0 theta, and I go -7. So I'm going to be in the negative x-axis. 1, 2, 3, 4, 5, 6, 7. Put a point right there. That's my first one. I'm going to go to pi over 2. Pi over 2 cosine of 0, I'm at -4. So go to pi over 2 and then go -4. 1, 2, 3, 4 points. I'm going to go to pi. Cosine of pi is -1. -4 plus, negative times a negative is a positive. -4 plus 3 is -1. Pi, -1. So I'm going to pi, -1, point. I'm going to go to 3 pi over 2. 3 pi over 2, cosine of 3 pi over 2 is 0. I'm at -4 again. 3 pi over 2, -4. 1, 2, 3, 4, point. Let's see, what else? 2 pi. At 2 pi, cosine's 1. 1 times -3 is -3. -4 minus 3 is -7. So 2 pi, -7. So 2 pi right here, -7. I'm back at that location. Here's how I look. Let's see, where do I start? 0, -7. I look like this. Oh man. Something like that. Cool or not cool? And I think we've covered all the situations. Oh, except for one where that looks like a heart. Let's go one more. Let's just do one more, guys. And I know there's not the most exciting stuff in the world. That one. Go to that one. Child, how do you know this one looks like a heart? Because it touches the x-axis, but it doesn't cross it. Child, what are you talking about? If I were to graph this, and I'm not drawing it perfect. I know, and it's not the most exciting stuff in the world. Look, midline's at -2. The highest it's ever going to go is 0. The lowest it's ever going to go is -4. I'm not drawing this to scale. It's not perfect. So here's how this wave is going to look. Does it ever cross the x-axis? No, but it touches it, but it doesn't cross it. Does that make sense? If it just touches it, that's what creates that little dip in there. That's what creates that heart. So look, I'm gonna do it again, and don't worry, I'm gonna show you guys all the ins and outs. And I know it's not the most exciting stuff in the world. I'm gonna put a 0. Cosine of 0 is 1. 1 times -2 is -2. -2 minus -2 is -4. So 0, -4. So here it is. 1, 2, 3, 4, point. The angle 0, -4. I go backwards. I'm going to put pi over 2. Pi over 2 is 0. Cosine of pi over 2 is 0. 0 times -2 is 0. -2 minus 0 is -2. So go to pi over 2, -2. Point. I'm going to go to pi. Cosine of pi is -1. Negative times a negative is a positive. -2 plus 2 is 0. There it is. Boom. That creates that. I'm going to go to 3 pi over 2. Cosine of 3 pi over 2 is 0, so I get -2 again. See? I'm going to go to 2 pi. Cosine of 2 pi is 1, so I'm going to have -4 again. So 2 pi, -4. So I am, let's see, I didn't plot the 3 pi over 2. 3 pi over 2, -2. Point. So it's going to look like this. Look, it's going to look like this, guys. Look, it's a heart. What do you guys think? Okay. Let's do some together. And let's see if we can figure it out. All right, guys, focus. Don't worry. I'm going to let you guys loose real quick. So look, so you have something like this. Graph the polar curve where r equals 4. If you just have this, you've been blessed. Bless up. It's just r equals 4 and that's it. So that just means you just have a circle. I push the circle and I just go to r equals 4. 1, 2, 3, 4. There it is. I just have a circle with a radius of 4. And that's it. So bless up. You don't have to do anything here. Look, it's not anything special. All right. Let's see if we got, okay. So you've been blessed so far. You have theta equals pi. There you don't have an r, just theta equals pi, so you just have a line. Here's pi, so you just have a line like on pi. And that's it. It's already done. As a matter of fact, you don't have to do anything to the line. It already comes out like that. And you're done, see? So those are not very interesting. Let's see. Okay, finally. All right, check it out. Your midline's at 3, and you're going to go above 5, because the 5 is the amplitude of the cosine. Above 5 from 3 and below 5 from 3. Are you going to cross the x-axis? Yes, you're going to cross it. And if you cross it, you create a loop. So it's going to be that one. Now what, Chav? How do I find the little loop? The little loop is the one that has a smaller magnitude, and the big loop is the bigger magnitude, the bigger value. So notice that I said magnitude. So look, if I type in a 0, so it's cosine, so I just care about 0 and at pi. At 0, cosine of 0 is 1. 3 minus 5 is -2. Do you guys see that? So I'm going to go to angle 0, -2. So this is angle 0, and I'm going to go to -2. So I'm going to be in the negative x-axis. So I take the little one, and I go to -2. Bam. See? And then here it is, cosine pi. Cosine pi is -1. -1 times -5 is a positive 5. What's 5 plus 3? 8. So at pi, I'm going to be at 8. You take the big one. Here's pi. Pi is this negative x-axis. I'm going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8. Before you push enter, it's correct. But before you push enter, you see that 3 here by itself? That means I should be at 3 up here. Let's see, 1, 2, 3, yep, and at 3 down here. 1, 2, 3. The radius is 3 from the origin, from the pole. I submit, and boom, yes. Now look, don't just push yes just to push yes. Look at this, guys. This is what I wanted to see. Look how when you cross the x-axis on the right, that creates that little loop. See? Oh well, okay. You know what? I wish I had the negative. If I had the negative radians, you would see that little loop created from this part to whatever that is. It's gonna close it way over here. Watch. Right. Okay. Boom. Across, and then boop. And where this one stops, this one would have began. So you would have seen that a whole region under the x-axis, which creates that little loop. We'll do another one that's gonna look better. Okay. Look at this one. The midline's -3. We okay so far? The amplitude is 2 for sine. So think about it. -3. I go up 2 and I go down 2. Will I ever touch the x-axis? No, you never will. So you're not going to have a loop, and you're not going to have a little heart, a little pointy thingy. It's going to look almost like a circle, like that, kind of flat. How do you do it? It's a sine. So let's look at pi over 2 and at 3 pi over 2, and then we'll verify it if I have -3 at 0 and pi. So at pi over 2, sine of pi over 2 is 1. 1 times 2 is 2. -3 plus 2 is -1. Does that make sense? So at pi over 2, I'm at -1. So here's pi over 2 and -1. I go backwards, so it's already there for me. Now, what about at 3 pi over 2? Sine of 3 pi over 2 is -1. -1 times 2 is -2. -3 minus 2 is -5. So 3 pi over 2, and I'm going to be at the positive x-axis, 5. So I'm going to count. 1, 2, 3, 4, 5. Now check it out. That -3 right here is where I'd better be touching the x-axis. 3 away. 1, 2, 3. Yep. 1, 2, 3. Yep. It works. Submit. See? And look. Wow. Check it out. See? Cool, right? It still is a lemicon. It just doesn't have that heart shape because we don't have a 0 there. All right, let's see. That's just a line. I don't care about that one. That's just a circle. I don't care about that one. Another line. Another circle. Man, look at all these easy ones. Okay. Look, amplitude is 3. Midlines is 2. Am I going to cross the x-axis? Yes, you're going to have one of those. I want a pedal. Let me do a pedal. They haven't given me a pedal yet. Where are my pedals? Ah! Man, guys, there, finally. I have a pedal. That's a 3. How many pedals do I have? Is it an even number or an odd number? It's an odd. So if it's an odd, you're going to have that number of pedals. If it's even, you're going to double it. So I click on pedals, and you have 3 pedals. And it's cosine, so you're just going to take cosine of 0, get it done with. Cosine of 0 is 1. 1 times -4 is -4. So at 0, -4. So I come down, and look, you already have the pedal. Here's 0, angle 0, -4. I go backwards. 1, 2, 3, 4. Done. You don't even have to worry about the other 2. See? And look, you can see why it creates it. Look, check it out. Boom. That's what I tried to do by hand. That's what we were doing by hand, guys. We're trying to plot little points at random points, at random theta values. Let's see if we can do. Look, another pedal, but I want a sine this time. Hold on, I want a sine. Come on, give me a pedal. Give me a pedal with sine. Okay, here's the pedal with sine. That's a 4. So how many pedals do I have? 8. So I'm gonna click pedal. I'm gonna put 8. All right, now what? Well, that's a 4. So I want this to be a pi over 2. I want sine. I want to get the biggest magnitude. So how do I get a 2? I got to go pi over 8. Does that make sense? So if I plug in pi over 8, you get pi over 2. If I plug in a pi over 8 for theta, right? Here, I know you guys are like, I don't know what you're talking about, child. I can see y'all's faces. Some of you kind of already checked out because you guys are really tired. So some of you are just looking at me for respectful, but like nothing's going in. And I get it. We're tired. I get it. Look. So look. Don't worry. We're almost done, guys. Theta R. I'm choosing pi over 8. Chop. Why? As soon as I see a 4, I'm going to put an 8 in the bottom. So look. If I go 4, sine of 4 times pi over 8. 4 goes into 8 twice. So I get 4 sine of pi over 2. And that's just going to give me 4. So 4. Do you see how I did that? Okay. Now, how am I going to graph this? I don't know where pi over 8 is. The graph doesn't have a pi over 8. Look, relax. Like this, guys. Let me screen capture this and show you like this. Okay. How do I graph the pi over 8? This is pi over 12. And this is pi over 6. Pi over 8 is bigger than pi over 12, but smaller than pi over 6. So it's somewhere like right there somewhere. 6, 7, 8, 9, 10, 11, 12. Closer to the 6 than the 12. Does that make sense? So I'm gonna put it right there, and it doesn't have to be perfect. I'll count it correct, and I'm gonna put it at 4. So between this one and that one, but closer like that. 1, 2, 3, 4. Something like there. 1, 2, 3, 4. Doesn't have to be perfect. And look. See? It doesn't have to be perfect. You just gotta. Matter of fact, mine was off a little bit. But look how it creates all those petals. Isn't that cool? All right, so I know you already did it, and I'm not taking away your grade. That's still fine. If you got 100 on it, you got 100 on it. I'm gonna put it back. I'm gonna put this activity again. Try really hard to see if you can do it without a calculator. And then if you got to use your calculator, go ahead. Don't teach your classmates a calculator yet because they don't know yet, guys. First period and fifth period. I know some of you already did because I saw someone in fifth period doing it with a calculator. Try not to show them with a calculator, guys. Try to see if you can do it by hand. Cool? All right. Good job, guys.